Hello, good afternoon. My name is Ronnie Kubat. I'm the co-founder of Tulip. We are a startup coming out of the MIT Media Lab. We're about 3.5 years old. And I want to talk about this whole idea of bottom-up transformation on the factory floor with the idea of manufacturing applications. So we'll start out with this glorious piece of stock photography, the one piece of stock in this presentation. This is effectively what is being represented, the future of manufacturing, what we have here in front of us, which is fully buzzword enabled. It has all the three-letter acronyms that you could possibly imagine. It has your blockchain, your machine learning, and things like that. But in most of the factories that I've visited, the reality is very different. And I see an enormous amount of manual operations, paper operations, which still exist there. And integration of new technology can be very challenging. So fundamentally, what our observations are is that those interfaces to machines on the factory floor, the things which are required for production, fundamentally are pretty terrible because they're not designed for the people who are the users of it, but instead they're interfaces designed for the machines. And this is in an environment which is incredibly complex, necessarily so, but there isn't really enough feedback for the people. So those process engineers, manufacturing engineers who are trying to figure out how to improve this process, they fundamentally still don't have the right kind of easy-to-use tools that can very quickly gather data, change a little bit of how things are going, experiment in a very fluid base. So in this environment, I see whiteboards with marker-drawn graphs on them, paper graphs, in these kind of silos where it's hard to mash up the data and try to look at correlations between things. So there is a very easy 15-step process to solve all this. You can formulate your problem very carefully. You can find some folks, if you don't have them in-house, to be able to solve this problem. And this represents, I think, a real inefficiency and a real slowdown in what's possible. So our approach is a little bit different. We want to enable the end-line manufacturing engineer with a set of tools that they can create their own applications, deploy their own applications to the factory floor for operators to use. So here's kind of the idea of these manufacturing apps. So first, sort of to explain a little bit of what that means. This is an application which might be, what you might be used to for having on your phone or on a tablet or something like that, except for, in addition to having some kind of logic and flow and instructions for operators, is tied into the physical world. So this is an important part of it because these people are in manufacturing, we're working with the physical reality, and that has to be part of these applications. So a manufacturing engineer builds an application, deploys that onto the factory floor where it's connected to different assets or sensors or like, and all of the execution of these applications by the associates who are actually doing the value-added work generates a ton of data. It generates some kind of standard set of data, it generates a bunch of heterogeneous data that you want to be able to take advantage of and use that to foster different continuous improvement efforts. So the kinds of apps that folks are building on the Tulip platform span a big spectrum. I think that probably the canonical example of this would be some kind of interactive visual work instructions. So something that is guiding an operator through some kind of, say, an assembly process where they're interactive because they're tied to the tools, they're tied to different safety checks or quality inspections that are baked into the process itself. And once you have these kinds of applications, there are a bunch of things that start to sort of flow out of this. So one simple example of this is about collapsing a feedback loop where you have, say you have a problem on the line, someone has to tell you about this, or you discover this in some way. You have to, go over, gather some data, get the anecdotes of the senior operators on the line who are actually doing the work, formulate some pivot table on all of this, print it out, put it on the board, have people interact with it, and now you can start to address the problem. So there's a huge feedback loop that's part of this. We want to collapse that into something that is much, much faster, that can be even real time. So by the use of these kind of applications and being able to collapse that, you can have improvements in quality, you can have improvements in overall throughput, and you can also have improvements on the way that you are training your employees. So these kinds of applications support things like classic lean manufacturing tools, everything from auditing and things like that, training tools that can bring new operators up to speed very quickly, up to at times 10 times faster than they would have done before. Especially true when you have a workforce which may be retiring out and you need to bring new workers in, or you have high changeover, or you have a surge in production that's required. Now you have to hire a whole new shift and then bring them up to speed into the production processes. So the other major impacts, I alluded to the quality impacts of using these kind of manufacturing app systems like Tulip. What we've seen is effectively the elimination of problems that are caused by manual errors. This is by providing better guidance and providing inline quality checks that are part of it. So as I mentioned, visual work instructions that can add increases in yield. So I'm going to skip over some of these use cases because there's quite a few, and focus instead on some example cases of what we've seen within with our experience working with customers. So New Balance was actually our first customer. They have really interesting problems because they are both high mix and high volume, and in the mix you have challenges of like, well, which mold did the shoe sole come off of, and which gender was it for, what size and style, what color of the materials, what is the mix of the chemicals, and you're doing this at the speed of fashion, constant new product introduction. So being able, being able to identify root causes of issues that exist on the line very quickly allows you to speed your time to market. And that's exactly how they're using the case. In the case of Jabil, contract manufacturer, we were used in sort of an NPI line, focused again on having quality issues be resolved much quicker, while in this case at the same time being able to improve the overall throughput of the production by double digits. Finally, in this case study with Merck, this is a training type operation where you could reduce the amount of time that it would take to bring a new operator up to speed by a factor of 10, and simultaneously bring the cost of training that operator down by 60%, just because you have less of your more senior staff that is there and watching over the shoulder of a new employee. So these are a couple of other ones I'm going to skip over just for purposes of time, or let them sit here. But a system like Tulip is now, what I mentioned is it's a bottom-up digital transformation, because it's for everybody in the team. It's something that the operators can certainly make use of, and allows them a channel of communications back to the engineering staff, that they can give comments, that they can be more participatory in the system, and allow that for the continuous improvement. The primary users are the process engineers who are creating these kind of applications, modifying these applications, analyzing the results from the data that's coming out of their execution, and then finally through the operational leadership, which now has a kind of visibility that can use this to share best practices globally. So those manufacturers that have 2, 3, 4, 5 facilities which have the same product being made, now you can much more easily share those best practices across the team and share those learnings. So as to the company itself, as I mentioned, we are an MIT spin-off. We came out of the MIT Media Lab. We're about 3.5 years old now, about 30 employees. We are now deployed across 9 different nations, mostly in North America and throughout Europe. We have a number of different partnerships from both McKinsey and BCG, from sort of the perspective of thought leadership. The DMDII in Chicago, which is an institute focused on showcasing some of the best technologies and digital technologies for manufacturing. So we have a booth in Hall 6. I'm happy to answer any additional questions. The other sort of important note about what we're doing at Tulip is the accessibility of this, as I mentioned, is from the ground up. So to make that easier, what we actually released yesterday is what we call a factory kit. This is like the idea of Tulip in a box. It is, a physical gateway and a light kit, which is effectively a digital and-on device, as well as a subscription to the Tulip platform with some variety of different kinds of sensors. Then an engineer can open the box, put together a couple of pieces, and deploy that onto the factory floor to begin collecting data within a day. So we're very excited about that launch and happy to talk about that more. Thanks.